Okay, recording is started.
Great. So welcome to our second WebEx session for Data 630. The last session we covered application prediction models. And to go over it, and we also wanted to demonstrate a random forest example. That's what I'm going to do first. First, install the package random forest. We're gonna call the library for random forest. All right. So we're gonna be using the same data set that we used last time, Iris. That has to do with types of flowers. Very basic and useful data set. Well, the thing we're going to do, we're going to set the seed, and the purpose for seed is really not so much to introduce randomness as to keep your predictions constant. So we're going to set the seed. I think it was 9850 last time. So we are yes.
On that, what number represent? I mean, does it matter whether you do 850 or 123 or?
No, just we use the number we used last time, but it really doesn't matter. I mean, I could put 470, and the purpose is to actually make your predictions accurate. In other words, it's not gonna start from a random number. So it's always useful to set the seed at the beginning when you're doing question.
Thank you.
So I'm going to work with the data set like we did last time. So it's going to be a little bit of repeating here. Basically, again, we are reordering the data set because the Iris data set by itself is pretty much in order, and we want to create some create randomness in the data set. We don't want them to be sorted. Yeah. So we're gonna truncate the data set into two parts, just like last time, into data set and the number of objects in that data set is 150. Oh, here it is.
And then on the first line, you had a comma and then nothing after it. But then when we're creating the Iris test set, you didn't have any commas. What does that comma represent?
Brad, can you repeat it one more time, please? I apologize.
For us training, You add 1:100, comma, but then nothing after that besides the closing bracket. For is.test, no commas at all.
I did an error in that one. I'm gonna rework it one more time.
So what does comma represent if it is supposed to be in both of them?
Essentially, comma setting, but here we don't really need it. I just mistyped. Join.
Hey, Naveen.
Welcome to the WebEx.
Hi. No, I'm looking at your screen. If you look at the line IRIS dot TRAING, I mean, it's a train or TIN?
Oh, yes, it's a typo. I'm sorry.
Oh, okay, not a problem.
So, yeah. Not sure here, quite honestly. I mean, it worked just fine before. Let me adjust. I mean, there will be. I'll have to get back to this one. Having a little bit of technical difficulty. So let me actually research this and get back to you on this. But I'm going to move on and demonstrate the.
The head comment something can give the first 100. Comment head probably. I don't remember exactly.
Head?
Yeah, like that. I don't recall the correct command name.
Well, head will.
Like that. Oh.
Yeah, the technical error. I think Michael had it before, where one of the arguments. Giving him an error, basically explicitly declaring an argument. Which was indicated data set. So when he removed data equals and just declared data set, it works. So I'm going to look into it and get back to you on this one.
The read statement to bring in iris, it's already there.
Right. This is one of the data sets that's already prepackaged inside the R. And in the next example for this association ruling, I'm going to also using the packaged data set. That will it's called groceries, and essentially. Association rule learning is a research method for relations between variables in the sets. Its intention is to identify rules discovered between variables using different measures, and the outcome of this type of technique is a set of rules that can be understood as if this, then that. And typically, and it's used widely in the industry. For example, anytime you see a recommend engine like Netflix or Amazon, essentially that's the association learning. Content optimization, like in magazine websites or blogs. And the most popular is to analyze the market basket. And market basket essentially is the economic indicator of the average price index. So in this case, we have we have what's called groceries, and we're going to try to analyze using association rule learning. We're going to try to analyze if a purchase of one or two products will, say, guarantee a purchase of another. In other words, if I buy, will I buy diapers? So for that, we'll need a few libraries, and I'm going to load them now. And I apologize for the technical issue with the first one. I'm going to get back to it. So the library we're going to use it's called A-Rules. Okay. So the data set that we're going to use is called groceries, and again, it comes with the R, so we need to do anything. So if we look at it, 169 items and 6 transactions. It's the summary of the data set. Again, it has a number of products like whole milk, vegetables, rolls, buns, soda, etc. So the A-Rules up here, library that we call A-Rules is called A stands for a priori, and it is an algorithm for frigging item set mining, and it proceeds by adding the frigging individual items in the data set and extend them to larger items as long as those items appear sufficiently often in the data set. Okay. Right. Assign the prediction to the variable called rules. And the a priori groceries. So parameters that we're calling are essentially we're specifying conditions. So we want support to be 1%. So in other words, we want to specify conditions where support is at least 1% and confidence is, let's say, so those rules, we want to set, we want to show the top 5 rules. So there's a number of rules, but we want to see, for example, the top 5 that are most likely to associate with each other. So first thing we're gonna to do that. First thing we're gonna do, we're gonna set the results to only 2 digits. And now let's look at the results.
Talk about limiting it to 2 digits.
Mm-hmm.
Does that mean they're only looking for a rule with 2 basket items together, not the 3s, not the 4s, etc.?
No, just the number. The actual number of associations, and we're going to get down to it later, is going to be around 3, sometimes 4. So it could be people who bought the items also bought that item.
Can you explain a little bit more what this options is? What kind of digits are being limited only to 2?
essentially, it's the precision digits. It's addition of making number two-digit numbers. All right. If we read output,
Oh, it's in your variables list. If you look at the environment.
all right.
Hi, Naveen. A quick question.
Mm-hmm.
You know, said how many transactions are there? Just want to see like how many transactions and how many items. Milk, yogurt, something is there, right? So I'm just wondering. You mentioned the option digit equal to 2, right? I think the 2 is for the combination of the item set. I mean, like the number of times the if you look at transaction 1, transaction 2, transaction 3, like that. The combination of the item set, like the person who buys diaper B can buy B also, like that's a combination. So I'm just wondering, like what is exactly that means? So options D equal to 2 you mentioned. So I'm that exactly. So can you explain a little bit more on that?
The combinations actually it's not the number of variables that are being compared to each other. More of a precision argument. For the variables, if we want to, I'm going to show later how to predict on a specific variable. For example, for milk, what do people buy before they buy milk, and what are they buying if they are buying milk? So,
But Faith, what do you mean by precision digits? You had already set support to 1% and confidence to 80%. So what else are you adjusting at that stage when you refer to precision digits?
So I'm trying to. So in other words, in the quality support, I mean the in the comments. Because I'm trying to bring the result to it, but for some reason it's.
Beyond Iris, and we were looking at groceries instead.
Oh, right. I apologize. Okay, it didn't generate any rules, so it's probably a mistake somewhere here. All right, following a priori. Without any parameters, let's just try to assertion on the whole data set. So if we look at the output, these types, or do you?
I should just try rules 1 through 5. Without spec, is it going to do this?
Out of bounds.
Oh.
That's strange, because it would work earlier, and I'm trying to see what. And again, I mean, it might be something in the arguments. We go down and type.
What else? There.
Okay.
It still works.
But it's what it would, what here essentially it would show the summary. For some reason, it's not fetching any rules. That means there's some sort of error in the way I construct the priori. But if this function would work right, it would show you a summary. We could see the number of rules generated. We could have seen how many items are in each rule. So in other words, we'd see if there's 3 items or 4 items or more. And quality measures, support, confidence, etc., etc.
The formula, you're allowed to abbreviate support and confidence to those 4 letters. You don't have to spell out the entire word support or confidence.
Right, no.
Okay.
I mean, well, let's try it without those. Sometimes it's funny how R works. Sometimes if you exclude some explicit declaration of arguments, I mean, it starts working. So let's just try that. All right. I'm doing it. Actually, what you can also do is, anytime you have you need sort of elaboration on anything, on data set, on a function, you can then question mark and then the function that you have in question, generated here. So here you can see how that works. So you the I priori. You have data source, which is groceries, and then declare your parameters. And parameters essentially a list, which is what we declare here. Maybe that's the problem. Let's try that.
Try 1.
I'm sorry?
0.1. How about if you try bigger number? Right.
Here, in support.
Let's happen.
Let's try 5. Something is off because it was the error is about
Hey, can you
range
try?
being about.
Support is 0.01. Confidence is 0.5.
So you want support at 1%?
Yeah.
Okay.
Yes.
Wasn't that saying that the would only work if it occurred 50%? If you saw that combination in 50%
Oh, there we
of
go.
the record?
Perfect.
Okay. So it should work.
Excellent. Great, and thank you very much. Excellent.
Okay, thank you.
Perfect. So we have some predictions, and like I said, this is the summary. Some rules about this. Number of rows generated. So 15 rules. Not rows rules. I'm sorry. The length of the distribution, left-hand side, right-hand side. Items long. Quality measures. So you can see the range of support. You can see the lift and the confidence. So the highest confidence we see here is with the third right here. I don't know. Support confidence. Okay. So let's try sorting the result, and to do that, we we'll get a sort function. Sorted by confidence. Sure that the with the higher confidence are on top. Okay. Now. So here we see that we have 50% confidence that people who bought citrus and root vegetables are also going to buy other vegetables. We have pretty high confidence on whole milk, related with groceries. Fruit, curds, other vegetables, tropical food. Let's cut to let's try to the first. Okay, so actually this is the algorithm, and this is how it associated the items in the data set between each other. Let's try targeting the since we have the whole milk. Let's try targeting the whole milk, and see. So see what customers are likely to buy before they buy whole milk. So create how we want the results to be presented. Yeah. So we sorted it to see the results of products that are what customers likely to buy milk. And the question that we
So you had typed a whole lot in there, and there's probably some good R lesson for us there about what those commands were: LHS, RHS, verbose, control. Can you walk us through what that was?
Sure. So LS and RHS essentially stand for left-hand side and right-hand side. Control is essentially when you LHS is left-hand side, and essentially you specify the default product. So when the algorithm is going through data set, I mean it's looking at what it's not selecting by anything, and right-hand side it's selecting specifically the whole milk. The verbose is let me just. It with the way parameters are spelled, but the example I was looking at had it set to false. So let me do a little bit more research on what exactly that means, and but really it should be set to false.
Didn't include that statement: control equals list, verbose equals F. Would it still work, or is that essential for being able to output something?
Really, I've seen that included. Let's remove it into default one. Okay. So what was the difference? So they changed. I'm not certain specifically. I mean, there might be a better answer for this question if I research it a little bit, but typically it should be set to false. Let me research it, and I will actually post it in the discussion.
Thank you.
Anybody have any other questions? You know, the algorithm that has associations is a priori. You know, the results we can target the whole. I mean, I'm sorry, the that we want to predict of by specifying it in the RHS parameter, which is right hand side. Yes. The hand, but I'm sorry, Dennis. Can you say one more time?
Say that the problem we're having was due to the fact that the confidence was too high because it was at 80% at that time.
Right. We were setting it to 80%, and the result. And again, I'm sorry because I ran this before the WebEx and it worked. It's probably some specification or maybe subsetting where it went off a little bit. But the maximum confidence we have here was almost 60%, and we were specifying you know, at least 80. That's why it didn't work the first time.
Having said that, what the impact of the support be if the support was lower than the 1% that you set?
Take on that one.
Support basically, item set support basically it's a frequency, so it controls the number of times that the item set appears basically. So you want to choose something that is frequent basically. That's what it's doing here.
All right.
Does it help?
Thank you. It helps.
Okay, got any other questions? Raise the hand, but I don't know. Mute. Tell me, are you on mute? Because we can't hear you.
Can you hear me now?
Yes. Excellent. Thank you.
Okay. I'd like to see the first 5 lines of the input glossaries. Once I would like to see how it's the data.
Comma. Oh, wait. How about if you try view?
Yeah, that's what helps.
This gives us just a summary. Okay.
It's not doing it. So, try.
Give the list of say milk, bread, sausage.
trying to see the content of the file?
Yes, first.
Or you can just open the file on your.
No, it's an internal. It's an internal.
Okay. And once if you just type groceries. No, it won't do it still.
That's actually what.
Oh, it's not.
That's okay. I was just curious how it's displayed in the database.
I apologize for you with that. I'm going to research it a little better, and I'm going to post answers to that on the discussion board.
Oh, okay, thank you.
So, anybody else have any other questions?
Yes, Brad, again, I have a general question. I don't know if there's an easy answer for it, but what you've shown tonight, what some of the videos have focused on also are the basics of support and confidence. And for the reading assignment for this week, that's, described fairly plainly in the first 10 pages or so of the reading assignment. A total of about 150 pages, and it goes off in so many different directions with FP growth and closed item sets and all those other things. And I just look at this and think, okay, I got what I need out of those 10 pages. What that's important from the other 140? So what are the other, at high level, are there some other really key things we need to be understanding about association analysis, for the rest of those readings?
This is very easy. The association at the very basic level, and if to perform the essential association, I mean, this is all you really need. And then, I mean, if you look in the help on association, I mean, it lists everything that you need to know about a priori right there. But as far as the reading assignment, this is what the background, and this is essentially what goes into amount of that you need, theoretical base that you need to have about association. But to perform associations themselves, that's essentially it, the a priori and parameters. And of course, I mean, you can also do the visualizations. Let me see if I can recall it. Priori. The package that lets you visualize your results, sort of like a decision tree in a way. Again, I'm not sure. I think it's called a priori viz, but I don't have it here. Maybe there is some library that I need to install, but essentially there are also options that you can do the output from your associations for that will help you understand the relationships better. But this is what you need to know. You just to specify your support, your confidence.
I was inferring from all those extra pages that there is something about in truth, this approach is only appropriate for certain situations, and these other situations, there are other tools that are that are more appropriate or something. But it really sounds like if this is all we remember, we're good.
For the basic level, yes, this is all you need to remember, because this is the association function in its very basic format. And there might be not every situation is basic, of course, and there are numbers of there might be numbers of other criteria that you need to specify and to get the right answer. But it's very basic.
So just to put that reading in context, can you provide an example of some kind of scenario in which what we've outlined here just wouldn't cut it, that you need a different approach or a more sophisticated approach to the association analysis? Big pages, it wasn't coming true to me why those that content would be relevant.
One example,
I'm sure there's a good answer. It just wasn't coming through.
You mean which content? I'm sorry?
Describe why someone would need any pages. You said this is very basic. So can you give an example of a scenario in which this basic approach just wouldn't be enough?
So there are situations where you have more than few variables. We only had, I think, 4 or 5 variables in this data set, but they might be more. And this is where you need to specify additional criteria. And the other case could be the size of the data set. Do you have any other examples of where it could be used?
Yes, I actually do, because confidence basically overlooks the rules that are frequent, but we might still be interested in them. So that there is a drawback in the confidence metric, because sometimes it does not consider the rules that occur less often but might still be accurate. So that's the reason we have to look at lift also. And the drawback of the confidence is that it does not look if the left-hand side of the rule and right-hand side of the rule are independent. So that's why we have to look at different metrics. And belief and confidence, don't look at the case when you have left side true perhaps and right-hand side is something different. The metrics they don't consider it. So basically we need to look at least 3 metrics. And I'm new to the R tool, but in other tools you can run the you can do the lead, and then there are like four different metrics that you can run. Because here I see just confidence and lead, but there is more. There is a conviction. So you need to run at least 3, because you want to not only look at the most frequent rules, but you want to consider if the left-hand side and right-hand side are independent. And another key point to point out is that the data set we're looking at, the data is already discrete. But if you look in the data set that has continuous numeric variables, you have to discretize it before you can run the a priori. So data pre-processing step, it's important, right?
That helps a lot.
Mm-hmm. Lacy, I have a quick question.
Mm-hmm. Yes.
When we were working on a classification, I personally had a problem. I was completely frozen. And after a while, I thought it was worth going back, shut down the whole system. And now I did that. The system asked me, I was working on the packages, and the system was just not recognizing the packages. And I have to go back and reinstall all my packages to go back to the console again before it starts working. Now, this is my question. Does it mean every time we're working in R and we get out of the console, we have to go back and load our libraries?
With RStudio, you can save your environment. And then, because every time you create a variable or, load the it's saved in your global environment. And here you can save your environment. In R, I think I normally work with RStudio, but with the R, I have to do it every time. Solomon. I think you're on mute again. Can you unmute?
Okay. So. Am I? Hello?
Yes.
Yeah, we hear you.
Hello. My feedback. Hello?
Yes, Solomon, we can hear you.
Oh, he's muted. I unmuted him.
Well, yeah, can you hear?
Yes, I can hear you.
Feedback on my.
I think you're logged in maybe twice, because I see your. Yeah. Anyway.
Yeah, hello.
Yeah, I hear yourself. Go ahead.
Yeah, back feedback. Yeah. Let me try and see. We're talking about the reading material, and so that's to provide the theoretical background for us, of all these things. You might ask the feedback is very, very bad, man. But in practice, so well, the software for analysis or this kind. Is that right? And what is available on the market?
Well, it depends, because you have a set of tools for set of commercial tools and open source. Commercial tools being a little bit more, first of all, they come at a price, and they being a little bit more intuitive. With ours, it was built by statisticians for statisticians, so it has the most extensive statistical packages. I think I wouldn't be wrong saying by out of most of the tools in the market. But for example, and again, there's a Gartner Magic Quadrant that is released every year that assesses various commercial tools on completeness of vision and execution, if I'm not mistaken. Typically, SAS and IBM are the leaders. At least they were in February this year. But it all comes down to really the few things. First of all, the price. Second, the adoption. How many can use it? Because for R, the learning curve is much steeper than for, let's say, SAS. And for IBM SPSS, it's even easier than for SAS. So it really depends on the criteria. But the basic statistical methods are shared between all packages. It could be some features, for example, SPSS doesn't have as data management tools as sophisticated as SAS does. And R is limited to a data set that you can load into R is limited to the memory of your laptop. So, I mean, there are different pros and cons, I guess, for each tool, but they all have the same statistical methods, essential statistical methods.
Okay. This program, can you be introduced to any of these packages?
Let me see if I understand your question correctly, Solomon. Can you're asking if you can write a package for?
No, can you be as we studying the whole association Can you introduce to some of the commercial packages? What will be these? Because I'm sure we'll meet them.
Do you mean if there are? I'm not sure if I understand your question correctly. Are you asking if there are association package a priori methods in the other applications, analytical applications?
The feedback is.
Oh, you're asking if association can be done in any other package?
No, it can be done. I'm saying that we have accesses to some of these packages while we are here studying.
In R, absolutely. R is open source, and any package that is not part of the default application, you can download it. And again, I mean, the easiest way to understand whether inside how the function is structured, what's inside the packages to essentially put question mark and type in the name of the function or the library, and it'll be in the help section right here.
Okay.
Thank you. Does that help?
Well, but is just about can't really with the feedback. So we'll end it there. Yeah, thank you.
Sure. Anybody else got any other questions?
No.
The tool that we've been using in the GBST program, it's called WEKA, W-E-K-A. It's developed by the Waikato University. Yeah, so that we have been using, but the plus side is a nice interface. You don't need to type commands. The minus side, less functionalities that you can do here.
And also, traditionally, academia uses using SPSS because the learning curve is so much easier. It's very visual. It's so much easier than other tools. But when you go into backend functionalities, definitely has better data management functionality. R has a much wider library of much wider set of libraries. There's also a tool called RapidMiner, which is, I think, it's even more easier than SAS, and they're adding features to work with Hadoop, and and it's pretty sophisticated, and it's point and click at the same time. But the R is it's essentially a standard for any companies that try and be for any startup, they're working with R just because it's open source and it's no cost. And there's also Python, but it's like with R, it's a command line, and a learning curve involved. But anything that's point and click, I mean, it has the same set of standard methods: RapidMiner, SPSS, WEKA, SAS. Other questions? Brad just joined us. Okay, I just wanted to reiterate. You had a question, is that correct?
Yeah, can you execute Can you execute the command item frequency?
Command frequency.
Yeah. Item, can you execute, like, I can, let me tell you, item frequency. Frequency. Do bracket, groceries, the.
Oh, perfect.
Okay.
Have you worked with that command before, Naveen?
Yeah, I'm just looking that one. So I executed last time, so I don't know exactly. It's okay. I mean, that want to check what kind of results are we getting on that. The item frequency means like what kind of value are we getting. I'm okay with that.
I think it's a percentage based on the values.
Yeah, if you want to see the proportion of the transactions, so like if you see the support level for item, the graph data, like we some have more supports like whole milk or yogurt or yogurt or pork, which will have more support. Those information if you want to see particular particular item information, like if you want to see support level. So this is the command. I'm okay, obviously. Thanks for executing. I think I'm done. Okay.
Well, excellent. So I think we're we're a little bit over an hour. If anybody has any questions, and I'd like to ask you to post them in the discussion section, and me and Elena will get back to you on those.
Mm-hmm.
Thank you very much for your time, and we'll look forward for the next one.
And pause the recording. We'll pause the recording in case you may need to look through again or anything.